Hi learners. In this session, we shall learn about various rules of differentiation. How to differentiate composite functions. How to differentiate implicit functions. Then how to differentiate inverse trigonometric functions. Then what about logarithmic differentiation, etc.
Differentiate sin x, it has got no meaning unless we say with respect to which variable we have to differentiate. So we have to write differentiate sin x with respect to x, or we can write derivative of sin x with respect to x. These are meaningful. So differentiate sin x is meaningless. Differentiate sin x with respect to x is meaningful, or we can write derivative of sin x with respect to x. So remember this. Here comes the relevance of derivatives of composite functions. Let us see what you mean by derivative of a composite function. Now let us study about derivatives of composite functions. When the function f is defined by f of x is equal to square of 2x plus 1, that is 2x plus 1 the whole square. This can be interpreted as square of polynomial of x, square of polynomial of x, because 2x plus 1 is a polynomial and then square. Therefore we can write that is square of polynomial of x. So that is nothing but s circle p, f composite p of x. That is why this function is a composite function. Now how to find the derivative of such a function? That is, if f of x, say y is equal to f of x is given by say 2x plus 1 the whole square, then how will you find dy by dx, or how will you find df by dx, or how will you find derivative of 2x plus 1 the whole square with respect to x? Actually directly we don't have the answer here. By any mechanism that you learned till time, we cannot find it. Then what to do? So here we suppose we put say v is equal to 2x plus 1 as a substitution. Then this expression becomes, that is d by dx, because our variable is with respect to x only, then v square. But we cannot write it to v. I told you the with respect to variable is very important. We can write dv square with respect to v, that is 2v, that is correct. But we cannot write dp square with respect to q, we cannot write that is 2p, that is wrong. So here is the problem, variable mismatching problem we can say. Here is the variable mismatching problem. Then how to tackle it? Okay, we want dy by dx, no doubt at all. That is d of 2x plus 1 the whole square with respect to dx we want. And if we substitute 2x plus 1 is equal to v, then this becomes dv square by dx. I told you we can find dv square with respect to v, that we can find as 2v. But here dv square by dx we cannot do anything. So what we will do is, let us change the variable with respect to variable to v, and then we can compensate by dv in the numerator. Then again we write. So what will happen? Actually dx is there and dx is here, and the effect of these variables will be getting nullified. So this technique is what is called, now we can find the derivative, you see. For example, now what is it? Now let us find, that is, I told you what is this? This is nothing but a 2v, so you can write 2v, and then what is v? We substitute, that is 2x plus 1 only, and you know the derivative of 2x plus 1, that is nothing but 2. So we have the answer, that is 4v. then you go back what is your v, that is 2x plus 1, or simply 8x plus 4 you can write. So actually this is what is called the derivative of a composite functions. Why it is composite function I explained already. This is a square of a polynomial of x, that is just like f of g of x. That is why it is called a composite function. Okay, now let us find what we have done actually. That is, we want dy by dx, but here what we are doing, just we are changing the variable. That is, we are writing derivative of y but with respect to v, and then dv, then we are writing again with respect to x. If we want, we can continue further. What I want to tell you, suppose we want dy by dx, then we can write dy with respect to say dv, and then dv, then with respect to, suppose we are putting say something dw, we are putting say dw, then again we can write dw, then we can complete by dx. So this way we can proceed. That is why it is called a chain rule. So it is a chain rule or function of a function rule. Why function of a function rule? I told you, this is just like square of polynomial of sine of x, something like this. So we can apply this rule. I can make it clear once again. One more example we will consider in the same pattern. So okay, let us consider say sine x square you want. We want the derivative of a sine of x square you want. So here we shall put say x square is equal to something v. X square is equal to something v. Then what happened? That is dx of sine v. I told you we cannot write that is a cos v. Derivative of sin x is cos x with respect to x. Derivative of sin v with respect to v, that is cos v. Derivative of sin x with respect to x, that is cos x, no doubt. But derivative of sin v with respect to x we cannot find. So there is a variable mismatching problem, because here variable in the function is at present v, but the requirement is derivative with respect to differentiate with respect to x. So there is a variable mismatching problem. So we have to tackle it. That is derivative of sin v, then with respect to v we can. So you write it. Then we have to compensate it by writing here dv, and then we will write dx again. So this is the way we can tackle the problem. Now what happens? Let us see. That is derivative of sin v with respect to dv. What is it? That is cos v only. That is cos v. And then d by dx of what is v? V is nothing but x square. So that also we know. That is very simple. That is cos v into derivative as squared, that is 2x only. Then we can write it as a 2x cos v, and finally we shall go back with v, that is cos x square. So this is the answer. So this way we can proceed with. One more example I can solve for you. Okay, let us consider the derivative of tan 2x plus 3. Tan 2x plus 3 with respect to x we want. We shall substitute say v is equal to 2x plus 3 like this. Then what happened? This is derivative of now tan v with respect to x. That we cannot. If we can find derivative of tan v with respect to v, that is equal to sec squared v. That is there. We can write derivative of tan x with respect to x. I told you the variable should be matching. The variable used in the function and variable with respect to where we are differentiating should be same. Then only we can write the answer secant squared x. So but here the problem here with respect to variable is x and the variable involved in the function is b. So there is a problem of a variable mismatching. So in order to overcome this variable mismatching, we are adopting chain rule, that is derivative of tan v with respect to v you can. Then to compensate we have to write dv, then we shall write again the required variable with respect to variable x like this. Then we can proceed. Then what happened, that is derivative tan v with respect to dv. I told you that is nothing but a secant squared v. So we can write a sec squared v into then d by dx of what is v? What is v? V is nothing but a 2x plus 3. 2x plus 3. So we can write that is equal to sec squared v into derivative of 2x plus 3, that is 2. So that is 2 sec squared v, that is equal to 2 sec squared v. V means 2x plus 3. This way we can complete the derivative. Okay, let us consider one more question. Find the derivative of say sine of cos of x square. So here we shall put two substitutions. That is, first of all we shall put x squared is equal to v. Then this will be d by dx of sine of cos v. But again, we are not familiar with this function. We cannot do the derivative in a single stretch. So we shall substitute cos v is equal to say something w. Then what happens? Our expression becomes d by dx of sin w. Yeah, we know the derivative of sine. If the variables are matching, then we can have an answer. So we are in a comfortable zone now. But the only problem is now variable mismatching. Otherwise we can. So here variable mismatching, there is a problem that we can address by means of a chain rule. That is, we can differentiate sin w with respect to w. So we shall write it, then compensate it with the w. And you can see w is a function in v. W is a function in v. And so we cannot write dx here all of a sudden. But since w is a function of v, we can write dv. That we can do. But I want to tell you, we can find derivative of w with respect to v. Why it is? Because what is w? W is a cos v. Then with respect to v. So variable same matching. Therefore we can, that I am telling. So here again to compensate we have to give dv, and finally the required variable dx we shall give. So now what happened? Now let us see, that is d by dw of sin w, that we can find. Then dw, what is w? W is a cos v. So with respect to v, that also we can, because variable is v only and variable is v only, that we can do. And then finally d by dx of v. V means nothing but a function of x. So again variable matching. So what I want to tell you, now everywhere variables are matching. Here it is w, here it is w, so no problem. Here it is w, v in the function, and with respect to v in the function, no problem. And here x is the variable, and here again with respect to x. So we can have the derivative. So what is it? That is derivative of sin w means cos w we can, and derivative of cos v means minus sin v we can, and then derivative squared, that is 2x. So that is equal to minus 2x sin v cos w, that is equal to, we have to go back, that is minus 2x. What is our v? V means x square only. So that is sin x square you can. And then cos w. What is w? That you can see please. W is cos v. W is a cos v. Therefore cos of cos v. And again that is minus 2x sin x square, then cos, then v means x square. So we have the answer like this. So we can have the final answer minus 2x sin x square cos of cos x square. That is the answer. So this way we can perform the chain rule or function of a function rule or derivative of a composite functions. We have to substitute the function in such a way that we are reaching a comfortable zone where we can do the derivative. And when variables are mismatching, we can overcome it by chain rule. That's all. Now let us study about derivatives of implicit functions. First of all, what do you mean by implicit functions? Here we can consider two functions. One is say y minus x minus pi is equal to 0, and another one is ax squared plus 2hxy plus by squared is equal to 0. Now in the first case, y is expressed in terms of x, or simply speaking, that is a relationship between x and y. And in the second case also, that is a relationship between x and y. But in the first case, the relationship between x and y is expressed in such a way that y can be expressed in terms of x easily. That is, we can find the value, we can express the value of y in terms of x so easily, whereas in the case of second, we cannot write, though there is a relationship, but we cannot write directly the y value in terms of x. Then in the second case, we say the function is a implicit function. This is an example of a implicit function, and this is an example of a explicit function. In the first case, this is called a explicit function, and here it is called the implicit function. That is, the relationship between x and y is expressed in such a way that it is not so easily we can find the value of y in terms of x. Then we can say that is implicit function. So we can write again some examples for implicit functions. Implicit function. Here it is for explicit function. For example, say sin x minus x plus y is equal to 0. Here you can write y is equal to that is x minus sin x. So easily we can find y in terms of x. So that is explicit function. But if it is given x squared plus y squared is equal to r square, or simply y squared is equal to 4ax, here all y and x are connected, but it is not so easy to express y in terms of x. We have to do many mathematical operations. In such a case, these functions are called implicit functions, whereas this is called explicit function. Okay, so that is about implicit and explicit function. So that is the relationship between x and y are expressed indirectly. That means if it is expressed directly, one can derive the value of y in terms of x. That is called explicit. Otherwise, it is called implicit. Now let us study about the derivatives of implicit functions. So first of all, let us study what about implicit function and explicit function. Let us consider two functions. Say the first one is y minus x plus sin x is equal to 0, and let us consider another function ax square plus 2hxy plus by square is equal to 0. No doubt in either case, both the functions are related, x and y are no. Now let us study about derivatives of implicit functions. First of all, we shall study what about implicit functions. Let us consider two functions. The first one is y minus x plus sin x is equal to 0, and the second one is x squared plus 2hxy plus by squared is equal to 0. No doubt here both the functions are relationship between x and y. But in the first case, we can easily find y in terms of x, that is like this. There easily we can find y in terms of x, whereas in the second case, though it is a function of x or x and y are related, but it is not so easy to find, not so easy to express y in terms of x. Then we can say this is a implicit function and this is a explicit function. That is, this is an example of a implicit function. Why it is implicit function? It's very simple. We cannot easily find y in terms of x. That's the reason. But here easily we can find it. Then such a function will be called a explicit function. That's all. For example, if we ask the question that will you go to Delhi this month, then somebody will say yes or no. So answer is a explicit way we can. Whereas the same question, if we ask it to somebody, then he or she may answer like this: oh, this month if I have some work there and if transportation facility available, flight tickets okay, then some emergency occurs, then I may go to Delhi. So there also final answer is a yes or no. But in order to conclude whether that person will go to Delhi, we have to manipulate something, that's all. So here you can see that explicit function means directly we can conclude y value in terms of x. But here it is not so easy to conclude a y value in terms of x, that's all. Now consider the implicit function x squared plus y squared is equal to say 4. This is an example of a implicit function. Then how to find dy by dx? Every time our question will be same, find the derivative of the function y with respect to x. Then what to do? So here the equation is x squared plus y squared is equal to 4. We can operate. This is what is called a differential operator. D by dx is what is called a differential operator. So we can apply differential operator on both sides of this equation. Then we know the summation rule, that is derivative of x squared with respect to x and derivative of y squared with respect to x and derivative of a constant, that is 0. So we can write it like this. Then what happens? Here you can see that there is no variable mismatching problem. Here x is, here x is. Therefore we can write directly x. But here there is a problem because there is y in the function and with respect to x a variable mismatching problem. So we have to address it. How to tackle that one? That is, we can find the derivative of y square with respect to y only. So we will write, then to compensate we will write y there and then we shall write dx like this. So that is equal to 0. Then which implies 2x plus. Now what is this? There is no problem because here it is y square and with respect to y. So we can write 2y. Then 2y into dy by dx that is equal to 0. We can cancel 2 because we can take it 2 as a common factor and then take to right hand side. So that is over. So we can write x plus y dash is equal to 0. Or we can write y dash is equal to minus x by y. Y dash means nothing but derivative of y with respect to x. Or we can write derivative of f with respect to x. That's why we are writing f dash x. So remember it. So in this way we can find the derivative, that is the required derivative of y with respect to x is nothing but negative x by y. That's all. Another example we can have, say ax square plus 2hxy plus by square is equal to 0. Again the mechanism is same. We can operate the differential operator on both sides, that is ax squared plus 2hxy plus by square, that is equal to differential operator d by dx of 0. Right hand side is 0 because derivative 0 is 0. And here on the left hand side we can write derivative of ax square first term and then derivative of a second term, that is a 2hxy, and then derivative of a by square. Then what happens? Now let us see. That is, here a you can take it outside as a common factor, then a into, then derivative squared with respect to x, so you can write that is 2x plus, then here we have to apply chain rule. So first of all we can take a 2h outside, then we can write a d by dx of xy. That is d by dx of by square, that is equal to 0. Oh, there we can write b outside, so that is, now suppose the implicit function is ax square plus 2hxy plus by square is equal to 0. Then how to find dy by dx? So here I told you we have to apply the differential operator on both sides, that is left hand side ax squared plus 2hxy plus by square is equal to, then again differential operator, that is d by dx, and right hand side is nothing but a 0. So what happened actually? So that is term by term differentiation or summation rule, we can say. That is d by dx of ax square we have to write, then d by dx of 2hxy we have to write, then d by dx of by square, and that is equal to 0 because derivative of 0 is 0. Then we can take a as outside, and then remaining derivative of x square, that is 2x, so that is over. Then here 2h you take it outside, then derivative of xy, that we have to use product rule here. Then here you take a b outside, then derivative of y square with respect to x, that is equal to 0. Now, which implies 2ax plus 2h into, we have to apply the product rule here. So we have to apply the product rule, that is first into derivative of second with respect to x plus second into derivative of first, that is x with respect to x, like this. That is what is called a product rule. Plus, and here what we have to do is, here b into, there is a variable mismatching problem because here it is y with respect to x only, so we have to change it, derivative of y square with respect to y, then to compensate dy, then we have to write the record variable with respect to which, that is x only, so that is equal to 0. Then what happened? Now we can proceed, that is 2ax plus 2hx dy by dx plus 2hy d by dx. What is dx by dx? Dx by dx is, what is dx by dx? Dx by dx is, that is 1 only, derivative of x with respect to x, that is 1 only, so we need not write it. And then plus b into, what is derivative of y square with respect to y? So that is 2y, so b into 2y, then derivative of y with respect to, so we have to write as it is dy by dx. That is the requirement, we have to find the dy by dx only. Then you can see 2 is there every time, that is 2 is there, so we can take it outside and cancel it. Then which implies ax plus then hx dy by dx plus hy plus by, then dy by dx is equal to 0. From this we have to group the terms in which dy by dx are there. So we have to group these two terms, and then dy by dx you can take outside as a common factor, The remaining hx plus by is there. Then we transfer the other terms to the left hand side, that is minus ax plus hy like this. In the last step, we can find dy by dx by transferring this hx plus by to the right hand side. Then it will be one division. So that is negative x plus hy divided by hx plus by. So this is the answer, that is the required derivative. Now derivatives of inverse trigonometric functions. Find the derivative of f if it is given by f of x is equal to sine inverse x. Then here we know that y is equal to sine inverse x, that is the given inverse trigonometric function. But equivalently we can write x equal to sine y. Our purpose is, given the function y is equal to sine inverse, what about dy by dx? We have to find this derivative. So here we have written x equal to sine y. So there you can have the differential operator on both sides, that is d by dx and dy by dx. Then we have to operate on the left hand side and we have to operate on the right hand side like this. Then what happens? The left hand side is nothing but 1 and d by dx of sine y. D by dx of sine y is that we can't do because there is a variable mismatching problem. In the function it is y, but with respect to x, so we have to address it. That is d by derivative of sine y. We can find derivative of sine y with respect to y only. So we have to write it like this. Then to compensate dy, then the required variable with respect to which, that is dx. So like this. So required variable is x. So that is why we are writing dx. Then which implies 1 is equal to. Now what about the derivative of sine y? That is very simple. So you can write cos y into dy by dx. So from this equation we can write dy by dx equals 1 by cos y. We can go back in terms of sine, that is 1 by square root, you know, that is 1 minus a sine squared y only according to trigonometry. Then we know what is square root 1 minus sine squared y. So what is sine y? Our sine y is nothing but sine y is nothing but x. So we can write in place of sine squared y, that is x square. So derivative of sine inverse x with respect to x is nothing but 1 by square root 1 minus x square. Now what about derivative of say cos inverse x? Here we can have two methods. The first method is as above, that is y is equal to cos inverse x. Like in the previous case of sine inverse x, we can proceed. That is immediately one can write cos y equals x. Then we shall operate both sides d by dx, the differential operator like this. Then on the left hand side, that is cos y, and that is equal to right hand side like this. Then what happened? That is here variable mismatching problem that we have to address, that is derivative of cos y with respect to dy, then dy, then we have to write the required variable x, then that is 1 only, you know, derivative x with respect to x is 1 only. That you know by the formula, that is derivative of x raised to n with respect to x is n into x raised to n minus 1. So here derivative of x means power 1 only with respect to x. So then you can write that is 1 into x raised to 1 minus 1, that is 1 into x raised to 0, that is equal to 1. This is the way we are writing 1. And don't think that one student once asked by a teacher to answer what is derivative of x with respect to x. He was saying the correct answer, but the method was wrong. That is just cancelling d and d and x and x. He is saying x. It is not the way. For example, once a teacher asked them simplify or express in lowest terms. So 16 by 64 and then 19 by 95 and then 26 by 65. One student, he might have heard from somebody that whatever is common to both the numerator and denominator could be cancelled off. So he was writing like this, then 9 and getting cancelled 1 by 5, and here 6 is cancelling, that is 2 by 5. Luckily or unluckily, the answers were correct, but the method is wrong. You know, in mathematics, not only the answer, but the method that matters. So that is very, very important. So derivative of x with respect to x is 1 only. Then which implies, what about a derivative of cos y with respect to y? That is negative sin y into dy by dx, that is equal to 1. So we can write that is dy by dx equal to 1 by minus, so we can put minus in the numerator, then sin y, that is equal to minus 1 by square root 1 minus cos squared y, and in the final stage we can replace, that is negative 1 by square root 1 minus x square. So we have the answer, that is derivative of cos inverse x with respect to x is negative 1 by square root 1 minus x square. But here we can have a different method also, because we may borrow one identity from inverse trigonometric functions, that is sin inverse x plus cos inverse x is equal to pi by 2, we know. Therefore cos inverse x is equal to pi by 2 minus sin inverse x. Now what happened? Now we can operate differential, we can have differential operator on both sides, that is d by dx of cos inverse x, that is equal to d by dx of pi by 2 minus sin inverse x. So the right hand side we can simplify. What is the derivative of pi by 2? Pi by 2 being a constant, derivative will be 0, so 0, then again negative as it is, then derivative sin inverse x, we know already, that is 1 by square root 1 by 1 minus x square, that is the answer will be negative 1 by square root 1 minus x squared again. This is an aliter or another method for finding it. Okay, one more question in this pattern, that is find the derivative of tan inverse x. So that is y is equal to tan inverse x is given, we have to find dy by dx. So you know, when y is equal to tan inverse x, that is tan y is equal to x, then we can apply the differential operator on both sides, that is d by dx of tan y, we have to write, that is the left hand side, and that is equal to, again we have to apply the differential operator, or we have to find the derivative, or we have to differentiate, that's all. So that is the left hand side, right hand side, that is x only. Then which implies, you know, here there is a variable mismatching problem. So whenever a variable mismatching problem comes, chain rule is there to help us, so we have to do it, that is d by dy then tan y, but we have to compensate with the dy by dx, that is equal to 1. So which implies 1, you know why, because derivative x with respect to x. Now what about this one, that is sec squared y then dy by dx is equal to 1 only, that is dy by dx equals 1 by sec squared y, that could be written as 1 by 1 plus tan squared y, that is equal to 1 by 1 plus, what about a tan y? Now you know tan y is x only. Tan y is x only. So we can substitute tan y as x. So that is x square. So you can write derivative of tan inverse x with respect to x equals 1 by 1 plus x square. That's all for today, and we shall come up with some other topic in the next class. Thank you.